Nothing happened. That's why not good. Okay. Yeah, last class we have completed for each loop and for each method. And today we have to learn and complete Stream API. Are you ready? Stream API is very easy. Only thing is one small diagram you have to understand. First, I will start explanation with the diagram. Then we will go for examples. And I'll show you few examples. With those examples, you have to start work yourself. And I will show you how you can work with those examples. I mean, where you can get more examples to practice. And while practicing, what are the different difficulties you may face, how to solve your difficulties by your own also, I will show you. Okay. It's very, very easy. Damn easy. Stream API. Only thing is more examples, more examples you have to practice. That's all. Number of cases you have to practice. Only cases practicing. Okay. So first 5 to 10 minutes is very, very important. And then we will go for examples. Tell me first point, you tell me what the use of Stream API or what the use of Stream. This is the first point you have to understand. What is the use of Stream API? What is the use of Stream API? It is used for number one, retrieving. Generally, people say shortcut. Let's say, let me also tell shortcut. It is used for processing collection of objects. And simple. It is used for processing collection of object. Collection of objects. I have so many objects available. I want to process them. Then what I have to use? I should use what? Stream API. Now the questions are what the meaning of processing? Okay, the meaning of processing is number one, retrieve the objects. Retrieve the objects from the collection. Retrieve the objects from the collection. Number two, hold those objects. Hold those objects. Not store. I'm clear. My word is clear. Hold those objects, not store. Storing is different. Holding is different. Okay, I'm stressing my word. Hold those objects. Okay, then second, third operation, perform mathematical operations. Perform mathematical operations like filtering, mapping, flattening. I'm taking N capital letter because there is a confusion. Flattering is there, flattening is there. Flattening. Okay, na? It is not flattering, it is flattening. Flattering means rising. Wow, super, your bumper. Okay, that is called flattering. Okay, na? You are praising that person, then we call flattering. Flattening means making smooth. There is a up and down is there, making smooth is called flattening. Okay, flattening, reducing, sorting, like this, etc. operations if you are doing. And then finally, fourth one, returning new stream object. This is very important. Returning new stream object with resultant object. So when you apply these operations, some results are generated. Na? With those results, returning new object. So what are the different operations you can perform by using stream object, or what the meaning of processing object. Okay, what is the meaning of processing collection of objects? Okay, what is the meaning of processing collection of objects? Retrieving the objects from the collection. Next, holding those objects. Holding those objects. Holding those objects. Then perform mathematical operations. Return new stream object. This is also very important. Returning new stream object with the resultant objects. Now, let me try to take one example. I am here, one collection is there. This collection contains the values 3, 4, 5, 6, 7. This is a collection object. It may be a array or collection object. Just I am taking small c collection. This is a collection of integers. Collection object. Then I wanted to retrieve only even numbers. From this collection, I want to retrieve only even numbers. First, what should I do now? Retrieve the objects from the collection. Okay. Here, I have to first retrieve the objects from the collection. Retrieve all objects. Retrieve all objects from the collection first. Simple topics are just you need to pay attention. Retrieve all objects from the collection. Okay, retrieve it. And hold. Retrieve all objects from the collection and hold. Where this? Just have patience. Once the diagram completed, full picture you will get, and I'll show you the notes part so that you will clearly understand everything. Diagram I have not prepared before because I want you understand live. It's not a YouTube video to prepare before and come, right? Then the elements are traveling from here. And then all elements come here, sir. After this diagram completed, I will introduce some terms. The terms are matching here. This diagram matching all the terms. That's why it's very important. Whatever the items available in this collection, everything come here. What are they? 3, 3, 4, 5, 6. All values are available here. 7. Sir, their line is available here, zigzag available. Yeah, that is a collection. Okay. That is a collection. And what is this, sir? This is stream. Okay. This is what? Stream. It is not collection. It is a stream object. So what is the difference between collection object, stream object? Collection object, store, stream object, hold. Right? What a collection object, store elements or stores values. Collection object stores values. What about stream object? Stream object hold values. How long? Until the operation completed. Until one operation completed, you hold. Once operation completed, it discard all the objects. For example, you have, for example, you take something called what? Something you take a tank. You have house tank is there, right? This is the tank. In the tank, you have water. This is the tanker. Tank has a water. Now from the tanker, pipe connections are there. And then through the pipe connection, you are taking the water into your house. Tell me, this pipe Store water or hold water? This tank store water. This pipe store or hold water. It doesn't store water. How pipe can store water, man? It will hold water. It will store water. Okay, that means what, sir? Now tell me. Now, for example, here you have applied what now? Tap. One tap you fixed. If you release this tap, whatever the water available in this pipe, everything is coming into your basket na or bucket na. That means the water available here, holding a, storing a, holding for moving to the next level. Holding the water to move to the next level. Okay, it is just storing. Is pipe there or not there or doesn't matter. Do one thing. You just take one pipe. Inside pipe you store the water. Can the water hold here? Can the water will be there? No. Either this side fall down or this side fall down. Okay, that is called holding. Pipe is not meant for storing water. Pipe is meant for holding the water to process. Then tell me, what operation I want to do? I want to retrieve the even numbers available. Then for that, we have to apply one operation. Listen carefully. We have to apply one operation on this stream object. I should apply one operation on this stream object and allow the object go out. And then first object, what is coming out? 3. Tell me, is 3 a even object? No, get out. Now I'm taking next object is what? 4. Is 4 a even object? Yes. You go to the next object. Go to the next object. Go to the next object. You are a even object. Okay, done. Go to the next object. This is the resultant. And now here what will be coming on storing? 4. Okay, done. Next coming object is what? 5. Tell me. First coming 3, 4. 5. 5 is even? No, get out. You are not allowed. Next coming is what? 6. Is 6 even? Yes. Go. Next coming object is what? 7. Is 7 even? No. Then stop. Tell me now, here what we applied? One operation we have applied. Then this operation taking the value one by one and return that required value. Return that required value. And then now this is a new resultant stream or not? And new resultant stream with what? 4 and 6. What is my target? I have a collection of different integers. Now these different integers, first I have to retrieve. After retrieving, first I have to retrieve. After retrieving, what are you doing? I am performing operation and I taken final result. Then tell me here to here how many stream objects we have? 2 stream objects. Number 1, all elements. Number 2, apply the operation and get the result elements. Okay, sir. Technology understood? Tell me, once results are ready, I have to take the results into my program or once results are ready, I have to take those values into my program. For that, what I need? I need apply one more operation. Tell me, this operation return the stream object or return the results? Return the results and store inside your local variable. Store inside your local variable. Local variable or store inside your bucket, whatever. If you take it as a, if you consider it as a water flow, then collect into your basket or bucket, whatever. समझ में आया? Then from here, 4 is coming and 5 is coming. 4, 5 are stored. Now this is your stream. Just go through once and I'll introduce my terminology. What is the use of stream API? It is used for processing collection of objects. Oh, 4, 5, sorry. 4, 6, 4, 6. What is the use of stream API? Stream API is used for processing collection of objects. What is the meaning of processing? Processing means first to retrieve all objects available in the collection. Retrieved. Step number 1, retrieved. Step number 2, hold those objects temporarily to apply one operation. Okay, holding. Perform mathematical operation like filtering, mapping, flattening, reducing, sorting. Okay, applied. Which operation I applied? Tell me. I have many objects. Among them, I don't want all. I want only few. Then what operation apply here? Come on. Which operation I have applied here? Filtering. Some of the values I'm stopping. That is called what? Filtering. I don't want all. I want few. That's why it's called filtering. Filtering. And then now create the new stream object. Return the new stream object with the resultant object. And finally we are retrieving that. So this is your stream object or stream operation. Now look at that. There is a pipe connection or not? What do you say? It's a pipe connection or not? One object to another object, another object, another object. It's a pipe connection. So a stream is nothing but pipe connection. Finally, tell me, what are you learning in this topic? Simply retrieving objects from the collection, performing mathematical operations, and returning the new stream object with resultant objects. Many people are saying that stream object will just meant for flowing data. Yes, it is meant for flowing data. It's meant for passing the objects from one state to another state. In between, what is doing? It is holding objects. What is the meaning of holding object? What is the meaning of storing object? Everyone tell me. Can I reuse this collection to perform one more flow of execution? Is it possible or not? Can I use the same collection to perform one more flow of execution? Is possible or not? Yes, I can do that. From here to here, one flow, from here to here, another flow, from here, objects are coming out. Can I reuse? What is the answer? Yes, it's possible to reuse. A collection of objects is reusable. That's why we call it as what? Store. Tell me, is this stream reusable or not reusable? Can I take the values from here to apply another flow of execution? Is it possible or not possible? Apply one more stream, apply one more stream, apply one more mathematical operation. Is it possible or not possible? That's why I'm saying a stream is a pipe. Already water is flowed. Already water went to the next level. In this pipe here, there is no water. Understand? Once this operation is applied and new stream return, this stream object, previous stream object is katam. Once the values are read and stored, this stream object is dead, destroyed. And tell me, is a stream object reusable or not reusable? Not reusable. Whereas collection is reusable. That's why what we are saying, collection is meant for storing object and stream is meant for holding the objects. It's not meant for reusing. It is not possible to perform same operation. So then, sir, what should I do? Sir, I want to perform same operation. Again, revisit collection object. Again, apply the new operations on the collection. That's it, simple. Again stream, again stream, again stream. Okay, streamer operation. Again streamer operation. Again streamer operation. Okay, first point, everyone understand holding and storing, reusing and not reusing? Everyone? Is in a diagram, able to visualize your real life tank. This is your real life tank and this pipe connection. Observe now. In your, okay, everybody nowadays in cities especially, how much worst state now. In villages also mineral water entered, In my village, people are drinking mineral water. how bad situation now the India villages also mineral water drinking and where is people health. Mineral water dangerous, Mineral water is good or dangerous? Danger to the health. Now in villages also mineral water entered. In my village, many people are drinking mineral water. Okay, whatever. It's good or bad. I'm another doctor to decide. Look at here. This is the tank. In the tank, okay, the water is not pure. In the tank, water is not pure. Then what will you do? You will extract the water from this tank. Extract the water from the tank and given to whom now? One purification plant or not? You are giving to one purification plant. Then tell me, is this purification plant exactly, Rama, okay? In my village also, people are asking, mineral water nahi hai? Filter water le ఏంట్రా బావి నీళ్ళు ఇస్తున్నా అసలు people are become crazy. If mineral water not supplied, people are not coming for next day work. This is how people are forcing. Okay. And now tell me, this is the tank, from the tank water coming to the purification plant. Now the purification plant clear the all the dust particles and that greenery things and everything, and then send that water to next level. Okay, send the water to the next level. Now what is doing in the next level? Next level, people are adding some minerals. Okay, extra minerals are adding. Right? And then now this extra minerals water is now coming out. Now the citizens, okay, or the workers of that factory, what they're doing? They're collecting this water into, they're collecting this water into where? They're collecting into dabba. Water bottle dabba. Array, 1 minute. Right? Feeling a dabba feeling? Maya, finally bottle came here. ఎక్కడ మొదలై ఎక్కడికి వచ్చింది చూసారా? Where it started, where it came. Now tell me, this is a tank. Not table, sorry, tank. And tank place, what is coming here? Plant 1. Water plant 1, where dust particles are removed. This is water plant 2, where minerals are adding. Okay. Then next, this is the final collection. Collecting point. Maya, your stream API completed, Babu. Okay, that's all. This is a stream API. Oh, stream API, you're crying, na? This is called source. This is a stream API architecture. Okay, this is source. And this is source where we have objects. From here to here, here to here, here to here. These are called intermediate operations. It's called intermediate operations. Intermediate operations. Okay, here called intermediate operations. And this final collecting the objects into final. This is collecting objects or collecting results, final results. It is called, can you tell me what? Guess terminology. Terminal operations. It's called terminal operations. So tell me, a stream object contains structure. What the stream object structure? Stream object contain three parts. Number one, source. Number two, intermediate operations. Number three, terminal operations. What is the first one? Source. Greenery. Greenery. Greenery means what? All dust particles available. Then next, coming what now? Intermediate operations. Blue color. All greenery is removed. Okay. Finally, what is coming? Terminal operations. You are collecting green at the yellow, purple. Okay. Red and danger. No, it's not red color. No. So finally, pure water is coming. That's it. This is the stream API. Now source, intermediate operation, terminal operation. What is this tank? Tank is nothing but collection object. Okay, tank is nothing but collection object. What is this plant one? Plant one is stream object one. This is stream object one. What is this plant two? Plant two is stream object. Okay, now easy na? Next, what is this operation? Obtaining stream. You are taking the objects as it is. You are not doing any extra machar. You are taking objects as it is. Obtaining stream object. Obtaining stream. Okay. Obtain the stream as it is, you take it. No any validations, no calculation. Just first you are collecting, obtaining the stream. Into plant one you have taken. And then what you did here? You applied. In this plant, you applied what? Operation. What operation? Filtering. Okay, filtering operation. Here you are processing. Okay, stream object is meant for what? Processing. Stream object is meant for processing. You processed. And the newly generated values you taken into this stream. Why are this stream? What are you doing? Again, you are obtaining new stream. Obtaining new stream with the results. You can say new stream with the results. Then after obtaining with new stream with results, can I again process that results or not? Yes. Again process the new results and generate new stream. Here again you are applying filter number 2. Okay, filter number 2. Okay. Then after adding filter number 2, final results are coming and sitting here. Then final results you are collecting here. This is not a stream object. Final results are collected. This is not stream object. Not a stream object. What is this? It may be system.out.println for printing, or a local variable, or a collection. If it is a single value, we can use local variable. If it is a if it is an object, if it is a multiple values returning, then it should be a collection. No, sir, just I want to print, sir, I don't do anything. Then you can use system.out.println. Okay, if theory understood, then we can start programming. Can you remember this Dabba diagram? This diagram, 2 diagrams. Everyone, online live students and WebEx live students, everyone. You confirm that you understand, then we can go for next step. Now let's start the programming. Programming means first what I require. First I have to create stream object. Stream of elements I have to create. Okay. Then next point we need to understand how many ways we can create stream object. How many ways we can create a stream object. First, different ways to create stream object. First, I can create stream object. Number 1, by using stream interface. A stream object is represented by the stream. Student represented by student. Employee represented by employee. Collection represented by collection. Similarly, stream represented by stream. By using stream interface factory methods. It has some factory methods. By using stream interface factory method. Where is this interface available, sir? How can I see everything? I'll show you. Okay. What I have learned, everything I'll show you. Don't worry. First one. To remember in collection interface, we have a method called off. Off is a where arg method, which will take 0 to n number of values. Like that. In stream interface also, we have a method called what? Off. Stream.off. Okay. We have some other factory methods available. This one sufficient. Second way, by using array object. How? Second way, by using array object. How? In arrays class, if you want to perform any operation on arrays, we have java.util package arrays now. Arrays dot, we have a method called stream by passing array object. Okay, pass array object to the stream method. Stream method returns what? Stream object to us. Here what I should write? Stream s equal to. Okay, stream s1 equal to. And here what is the another way we can create? Stream s2 equal to. Okay, stream s2 equal to arrays dot stream of some array object. Which array objects are your wish? Any type. Int array you can pass. Let me write object. Object where are they writing? No. Okay. Any type of object you can pass. Then next. Third approach. I'm deleting this one to confuse it. Third approach is by using collection. Third approach by using collection object. Third approach by using collection object. C capital letter, not map, only collection. How? Stream s3 equal to any collection object dot method name is what? String. Any collection object dot string. Okay, fourth one. By using file lines of file. By using lines of file. Okay, how? Stream s4 equal to, buffer reader object. Buffer reader, how to read the data from the keyboard, from the file by using buffer reader. Buffer reader dot, there is a method called lines, br dot lines. Okay, so these are the 4 basic ways we can obtain the stream object. Different ways to create stream object: by using stream interface factory methods, by using array object, by using collection object, by using lines of file. So these are 4 approaches we follow for creating stream object. Shall we try one example? I will use Eclipse now, not Edit Plus. Yesterday I was preparing the notes. Previous notes I have already, but I want to prepare better. Okay. Do we have stream support also? Yes, we have stream support also, Vivek. Look at here. So many points are there. I'm not going to speak all points. First, I want you to understand. Whenever you are working with stream, okay, first you have to understand there is a root interface called base stream. Okay, base stream is the super interface of all types of streams. There are 4 types of streams are there. Stream common to all types of objects. Int stream only for working with integer values. long stream to work with only long type values, double stream to work with only double type values. Then following by collector. Okay, we have as he's saying that, let me also add. Actually, I thought of to ignore it because you asked me. Let me add. Stream support one interface is also available, but I ignored it. 4, 5, 6. Now stream, into stream, long stream, double stream. These are the 4 types of basic streams we are using in the program. I don't know what type of objects are coming. Maybe integers, maybe long values, double values, float values, char values, boolean values, example object, sample object, employee object, student object. I don't know what type of objects or values are coming. Then work with stream. I know the coming values are integers, work with int stream. I know the coming values are long, work with long values, long stream. I know the coming values are double, work with the double stream. Okay, now I want to create a stream. To create stream, we have how many ways? We have a stream. Stream contains its own factory methods, and we have array to get the stream. We have collection to stream. We have file to stream, and also we can create stream by using stream support interface methods also. Okay, then tell me, after all these stream operations means intermediate operations completed. Okay, intermediate operation, intermediate operation, intermediate operation, intermediate operation completed. Finally, we have to collect all the values now into final destination. To collect all values into final destination into a bottle. What is this bottle? It is also collection only now. This collection is nothing but collector. So collector will collect the all values. Okay, how can I collect, sir? How can I get the collector? Collector is also not class, it is an interface. Then how can I create the collector object? For that we have a class called what? Collectors. Collectors class is used for creating collector object. There are several factory methods available to create collector object. While working with stream, while you are retrieving one elements to another element, there is a chance we may get null values also. No? To handle this null value, I should write if condition. If I write if condition, again you are going back to the logical programming style. I want object-oriented programming functional style. No? So to avoid this if condition to write to handle null, we have a special class called what? Functional class. So this functional class is used for handling null values. So again repeating, I have a collection. Now this collection contain what type of elements I don't know. Use stream. I know it has integers. Use int stream. I know long values. Use long stream. I know double values. Use double stream. Point number 1. Then now after performing these stream operations, what operations? Intermediate operations. After completing intermediate operation, final results are ready to collect. For collecting final results into a collection object, we have to use what? Collector and collectors. Collector and collectors you have to use. Okay. Now while I am processing data, okay, one stream to data moving to next stream, one stream to data moving to next stream, one data to moving to next stream. Then while moving the data, there is a chance internally we may contain some null values are available. How to handle that null values? By using optional class. So first of all, stream internal contain all these names are understood or not? Next, stream is a connection. It is a connection between source object. Stream is a connection between source object. Internally, one pipe connection is created. That's what I told. It is a connection. Tell me, once the stream operation completed, I have to close this connection, right? For closing this connection, it is made as what? Auto closable subtype. When it is an auto closable subtype, I can create the connection and automatically we can close connection by using try with resource. Remember Java 7 feature try with resource. The stream object I can create as part of the try says automatically this connection is closed once its usage is completed. So that's why they made it as auto closable. Before that, it is not just a closable type. Up to initial version, it is just a closable type. In the latest version, they made it as auto closable. Earlier, we had to call close method. Explicitly, we had to call close method to close connection. Okay, then now onwards, it is made it as what? Auto closable. We don't need to call, just to use try with resource. So whenever somebody says stream API, immediately what is the idea should come to your brain? Number one, base stream. Number two, stream, int stream, long stream, double stream, stream support. Then collectors optional. So if you remember these names, then first initial programming will be very easy. Everyone accepted? The next step. What is a stream API? Why stream API? A stream API is a set of classes and interfaces. Look at that. This is a class. This is a class. These are the interfaces. Hello, did you notice? All these are available in which package? Java.util.stream package. But optional class is not available in java.util.stream. It is available in java.util because it is common to all classes in the project. Anywhere you can use optional class. But these are allowed to use only with stream programming, but it can be used with normal programming also. That's why it is given in java.util package. So a stream API is a set of classes and interfaces. It is used for processing collections of data in a functional and declarative way with less code. In a functional and declarative way. Functional means lambda expression. Declarative means just we are saying what you want. You are not writing logic. Just you are saying what you want by calling the method, and that process you are sending the operation by logic by using functional programming, and you are telling you apply this logic by using what? Declarative way. What is the meaning of declarative way? Just you are calling a method. Processing means retrieving objects from the collection and performing different mathematical operations like filtering, mapping, reducing, counting. Stream API helps in operations such as retrieving, filtering, mapping, flattening, and reducing collections effectively. Okay, flattening, not flattering. See, I also did mistake. Sometimes it will be confused. Flattening, flattering. Okay. Now, so mapping, after mapping, flattening, after flattening, reducing count. That's why N you read capital. Filtering missing. Okay. Oh, it's a filtering. Yeah. I read wrong. Sorry. Filtering, reducing, flattening. Okay, done. Now, what is the difference between collection and stream? A collection is for containing objects, whereas stream is for processing the collection. Containing or storing. Next, what are the different operations performed by using stream API? By using stream API, we can perform below operation: retrieving, holding, returning, and performing. Performing aggregate functions. Aggregate functions like filtering, mapping, all same names are again and again repeated. Okay. Any question may ask by the interview. Next, why stream API is required when we have iterator for each loop, for each method. The iterator for each loop, for each methods are just for retrieving objects from the collection. Just retrieving objects from collection is not sufficient. After retrieving objects, we must also perform some aggregate operations like filtering, mapping, flattening, FLATT. Okay, reducing, counting, checking, consuming, etc. operations. For performing these aggregate operations, either we must define our own user-defined method or take help of the inbuilt methods. The iterator for each loop and for each methods are not providing any inbuilt methods, not providing inbuilt methods to perform above aggregate operation. We must define our own methods to perform those aggregate operation. In every project, all developers must write same logic, which becomes redundant. This problem is solved by Java 8 by providing stream API in the package java.util.stream. Everyone tell me, stream API is providing functional interface and lambda expression, methods to execute functional interface lambda expression. Stream API providing methods to execute lambda expressions. Are you following my point? Try to understand. Stream API not providing functional interfaces and lambda expression. Stream API is providing methods to execute lambda expression. Tell me, here I want to perform filtering operation. To perform this filtering operation, I need one method with logic or not? I want to perform mapping operation. For that, I need one method with logic. I need to perform flattening operation, reducing operation, counting operation, checking operation, consuming operation. To perform these operations, I need one method with logic. Na? To what you want to filter, I will give logic. For that, lambda expression is there. What you want to map, I will give logic. But execute this logic for each object available in the collection. Further, for each loop, I have to write. Who has to write? Stream API will write. Everyone understand? Stream API provides several inbuilt methods to perform aggregate operations with the given lambda expression on collection of objects with given lambda expression. Okay, with the given lambda expression logic, very important. So lambda expression logic we are passing to these methods, and these methods performing operation on this collection object. So don't confuse. Stream API means set of methods to perform operation. To perform those operations, I need supply logic. That logic to supply functional programming we are using. That is called the word. What is that? Declarative. Where is the first word? Somewhere I have written. Yeah, functional and declarative. Functional means lambda expression. Declarative means just calling the method. That's it. When I see the code, you will understand. What are the advantages of Stream API? I have listed out the Stream API advantages. Concise and readable code. Okay. And next, improved performance with parallel processing. Functional programming paradigm we are using. Lazy evaluation. Supports various operation. Supports infinite streams creation. Enhances code maintainability. Better resource management. These 8 features, if I explain also you don't understand at this stage, going on you will understand. Don't worry. Just a note spot I have written. Next, working with Stream API is as simple as DB queries. Working with a database is Stream API, both are same. Stream API is nothing but select query with where and or conditions. And tell me, I have a table, buddy. I want to retrieve the results from the table. How can I write the code? Tell me. Select query right now. Select star from where student table. That means what? Retrieving all the records available in the table. No, I don't want all. Then you are writing what? Where course equal to, where course equal to, you are adding what? Core Java, na? Okay. And faculty equal to, you are writing what? HK, na? And institute equal to, what do you write now? Naresh IT. Something you are writing like this. Bolo. Here, what is this? First step, you are retrieving all records. This is the source. Second, you are applying for intermediate operation 1, intermediate operation 2, intermediate operation 3. And then finally, all the results are written. That is what? Terminal operation. So if you remember database queries, how to work with select query, working with Stream API is a damn easy. Look, you can consider a collection is a mini database, and next Stream API as SQL for retrieving and processing database data. For retrieving objects from database, we will use select query. For retrieving objects from collection, we will use Stream API. Where condition nothing but filter 1. And is nothing but filter 2. Or is nothing but filter 3. Order by is nothing but sort. These are all what? Intermediate operations and source. Everybody is able to understand this explanation from this diagram? I told you, if you remember this diagram, explanation is easy. Okay, applying intermediate operations. Let's proceed. Look at it. What is a stream now? Stream API completed. Now understanding what is stream. A stream is a flow of values or objects from an array or collection or file or socket. Look at that. A stream is a flow of data. Data flowed, data flowed, data flowed, flow of data. Okay. Next, what is the stream exactly? A stream is just a connection to a source of data or objects. We can consider stream is a pipe connection. Look at this pipe connection. From this source, one connection created. This is stream. A stream like a pipe meant for flowing data from one operation to another operation. Okay. Now, from this source, data flowing to one operation, again flowing to second operation, again flowing to third operation. A stream cannot contain or store values or objects. It's just used for holding values or objects and passing those values or objects to perform different intermediate mathematical operations with less code in a functional and declarative way. Now look at the values are passed and apply the mathematical filtering. Again pass, apply the mathematical filtering and then storing. Okay, how you are applying that mathematical operations? Via functional programming style with a declarative approach. Why stream? A stream is used for retrieving values or objects from array or from a collection for processing those values and objects. Very, very important. Always you say what? Processing, processing, processing. Next, can stream modify a collection? No, it doesn't modify. Look at the stream, what is doing? It is taking values and store in a temporary memory, apply the operation, generate the result. Again return the result as what? New stream object. Apply the operation, returns what? New stream object. It never ever go back to the collection and do touching, either removing or modifying or anything, updating or deleting. Nothing it will do on the collection. It always retrieve the objects from the collection and in its own temporary memory it is doing all the required operation. Okay, can stream modify collection? Never. Okay, the stream object structure. A stream object contains three parts. What is that? Source, intermediate operation, terminal operation. Look at that. Source, okay, and intermediate operations and terminal operation. How many intermediate operations we can apply? Multiple. How many terminal operation we can apply? Only one, only one, only one, only one. Yes or no? Already after collecting values, how can I apply? 0 to n number, terminal operation only 1. You cannot apply 0 to n number. Terminal operation is only 1. Next, how can we create a stream object? We can create a, obviously source is only 1. Na? How can I create a stream object? We can create stream object in 4 ways. Stream of, stream dot of, into stream dot range, stream dot iterate. 4 ways. Using array object, arrays dot stream. Using collection, call dot stream, call dot parallel stream. Using lines of file, buffer reader dot lines. Next, what are the different operations you can perform on a stream object? On a stream object, you can perform two, intermediate and terminal. What are operations are called intermediate operations. Sir, just by seeing the method, how can I identify it is an intermediate operation or a terminal operation? Look, when you call a method, for example, filter, when you call method, if its a return type is stream, then it is a intermediate operation. When I call a method, if it return type, for example, collect method I am calling. Collect method return type is not stream. If it is not stream, that is what? Intermediate operation. Are you following? Sir, how can we identify it is an intermediate operation or terminal operation? To identify it is an intermediate operation or not, look at the return type of the method. If return type of the method is stream, then we say it is an intermediate operation. If return type of the method is not stream, then we should call it as what? Terminal operation. Tell me, once we call terminal operation, still can I proceed with that intermediate operation? Still can I use that object? No. Khatam. Again, you have to start from the beginning. As long as you didn't call intermediate operation, as long as you didn't call terminal operation, you can continue the stream. Once you call terminal operation, you cannot proceed with that stream. You have to start again from the beginning. Okay, nobody, everyone? Just I am giving clear notes. The operation, those process collection of objects and returns a new stream object with the resultant objects are called intermediate operation. Filter, map, flat map, reduce. The intermediate okay, sort also let me write. These are the most commonly using methods. The intermediate operations are applied in between source and terminal, and we can apply multiple intermediate operations. Okay, listen. Tell me, sir, once a filtering completed, filter operation will do on one object now. Try to understand, it's a little difficult. First object has taken, given to lambda expression. Okay, lambda expression told, array it is a not even number. Then in a stream object, that object is not stored, ignored. When you go for second object to verify, is the first object stored in its buffer or not stored? Not stored. 3 is gone. Next coming object is what? 4. This 3 is gone. That means this filter operation is stateless, stateful. If previous data is remembered, then we call it as what? Stateful. If a previous data not remembered, it is called what? Stateless. Tell me, sort operation you take. Sort operation you take. Sort, it is having multiple objects. 3, 7, 4, 2, 5, 6. Tell me, if you take first element without comparing with the next elements, by forgetting these 3, can I process with 7? No. By forgetting previous, can I process with 4? No. By forgetting previous, can I process 1? No. That means sort operation is stateless or stateful? Stateful. Filter, map, flat map are stateful or stateless? Stateless. This is the most important point. Many people don't know. This is a new point, very important point. Types of intermediate operation. Intermediate operations are divided into 2 types. What is that? Stateless, stateful operation. Stateless operations such as filter and map doesn't retain, return and keep it with them. Doesn't retain any state from previously seen element when processing a element. When processing a new element, it doesn't see the previous element. Each element can be processed independently of operations on other elements. Stateful operations such as distinct and sort. Tell me, if you want to say this object is distinct or not, I have to compare with the previous object or not. May incorporate state from previously seen elements when processing new element. One cannot produce any results from sorting a stream until one has seen all elements of the stream. Are you following? Without remembering previous objects, next objects you cannot process. Then that intermediate operations are called what? Stateful. Without considering previous object, we can process the next objects. Then we call it as what? Stateless. The next, what operations are called as terminal operations? The operation that is applied at end of the stream and returns result from this stream is called what? Terminal operation. For each, collect, to list, count, max, min, or comes under what? Terminal operation. The terminal operation will not return stream object. It prints or return final result. What is the meaning of intermediate operations are lazy? Very, very important. Intermediate operations are lazy operations. Lazy ante like you, it is a badagastulu. Just by calling sort method, elements are sorted? No. Tell me, water from the tank coming to the pipe. Without releasing the tap, is water automatically coming down? Without releasing the tap, is water automatically filtering? In your house, you have filters now. In that filter dabba, water is available or not? Is that water automatically filtered there? No. When the terminal operation you called, then only filtering is going on, isn't it? What is the meaning of intermediate operations are lazy? Until we call terminal operation method, intermediate operations are not executed. For example, I call stream.sort, but I didn't call any intermediate operation. Is sort method logic executed or not executed? Not executed. Just ignore it. Just by calling filter method, the stream objects are not filtered. Okay, stream object is not filtered until we call one of the terminal operation like for each count. Okay, where intermediate and terminal operation methods are defined. All intermediate and terminal operation methods are available in the interface stream in the package java.util.stream. The list of intermediate operations, first one filter, second one map, third one flat map, distinct, sorted, peak. Method name is not sort, method name is sorted. Okay, so all these methods, filter, map, flat map, distinct, sorted, peak, limit, skip, all these methods comes under what? What you call intermediate operation. Some of the methods I mentioned, remaining methods list also I will provide you. The intermediate operations are useful for transforming, flattening, not flattering, transforming, flattening, filtering it is. Filtering and manipulating the elements in a stream before performing a terminal operation. By chaining multiple intermediate operations together, you can create complex stream pipelines that perform advanced data processing tasks. Hello, you know join? In database, we have join operations now. Join. Inner join, outer join, inner outer join. As much more filtered data you want, those many extra joins you are adding or not? Similarly, you can add multiple intermediate operations. You can pipe connections, pipelines connections you can create to process the data. Okay, terminal operation. The stream interface in Java it provides set of terminal operations such as for each method, to array, to list, reduce, collect, min, max, count, any match, all match, none match. All these are comes under what? Intermediate operations. Sorry, terminal operations. Means are these methods returns stream object? No. They returns what? Final output. These terminal operations are used to produce a result or side effect after performing intermediate operations on a stream. By combining intermediate and terminal operations, we can create powerful stream pipelines that perform complex data processing tasks. Final conclusions are, in simple terms, we can conclude stream API and its operations is called select query with a where condition. Below program shows obtaining stream object, applying intermediate and terminal operation. Before that, remember very important point. One second, I wanted to, this is a Sun Microsystem document I copied yesterday. So I will write it there, leave it. Very important point. What is that? Once terminal operation is completed, you cannot use that stream, you cannot reuse the stream. If you want to construct the stream again, what you have to do? You must again start from the zero. So just whatever I have explained the diagrammatically, the same diagram I have shown you in the notes part. Everybody understood? Okay, tell me, everybody diagram come to your brain? Whenever somebody says stream, immediately what you have to get to the point? Okay, point number one, source. Point number two, point number two, intermediate operation. Excellent. Point number three, terminal operation. After how many intermediate operations we can apply? N number. Each time it returns new stream object. Okay, each time it returns new object with the results. Next, how many terminal operations we can apply? Only one. Once a terminal operation completed, can I reuse that stream? No. If we want same results, what should I do? Again, I should repeat. Shall we start program now? Waiting, sir. Waiting program. Last 1 hour you are talking about only theory. Boring. Without theory, programming will not understand. Stream API that much difficult. That's why I keep on saying, Babu, Stream API easy when you are good at theory and lambda expression usage. Let's start. Enter the drag. Very easy. Final conclusion, database queries, Java Stream API, both are same. Let's start one by one. I have prepared several test cases here for your understanding. Let's see how many test cases you will understand and how many you will remember, how many you will understand. Ready? First case I am taking. I want to follow. How many ways we can create stream object? 4 ways. Na? I want to create all 4 ways. First way by using stream.off method. Look. Stream.off 2, 3, 4, 5, 6, 7, 8. Tell me what this is called. This is called source now. Stream object with elements stored a holder. Here stream object is created with all these elements for temporary holding. Now on this stream object, can I directly apply terminal operation? Terminal means no, there is no further processing. Then data is going and print. Just I want to read the available objects in the stream and printing. I am not going to do any extra operations. Do you all people remember for each method? For each method takes consumer as a argument. Consumer is functional interface. A functional interface method, one parameter functional interface method without return value. Then can I take one parameter as a lambda expression and implement it? Lambda, parameter and logic. My target is only printing. So this is a source and this is terminal operation. Am I collecting values or printing values? Anshika, Friday notes. Friday notes not uploaded, man. Okay. I'll check and update. No problem. I'll look at the all values are coming or not. Bolo, all values are coming or not? Yes. Now my question is very important. Sir, I can also retrieve all the values. I can store values in array and retrieve values from the array or collection using for each method. Why extra stream, sir? For each method can only allows us to retrieve elements, but I want retrieving by filtering, by mapping, by flattening, by reducing. So many logics I have to develop. For those many logics, I have to write several number of methods now. Stream API providing those methods. For example, I can store data A, B, C by using char array. Char array equal to floor bracket, single quote A, single quote B, single quote C, right? Why you are using string then? If you use char array, I can store, but later after retrieving, I want to perform so many operations. This character is uppercase or lowercase, a character that this a lot of operations I want to perform. Can I do that operations? No. I can store data, I can store objects E1, E2, E3, E4 by using array object. Then why are using collection? If I use array, I want insert the object, remove the object, replace the object, sort object, several array based operations I want to perform. For that I have to define so many methods. Instead of you defining methods, the required methods are available in collection. So same way, after collecting the objects, I want to perform so many operations, not just printing, many other operations before printing. Those values, those operations to perform required methods are available in stream. So habituate working with stream. Now tell me, I want to create, instead of typing these many values, I want to create a source from 2 to 8. Just I write 2 comma 8. I want to create a stream with the range of values 2 comma 8. Can I use the range method? Yes. Then source object is created stream object with 2 comma 8 and just retrieving stream 2 dot for each. For each available in the stream, retrieve and give to me, I will print. Any point you don't understand, please let me know. Look at that. 2 to 7 only coming. Ayyo, 8 is missing. Why? 8 is missing. Why? Remember a string handling chapter? End is always exclusive. End is always exclusive. Only begin is, start is inclusive, end is exclusive. Sir, I want 8 also. Then write here 9. Understand the range method? Now, so these two are meant for creating the stream object by using stream only. But I have the elements in array. How can I create stream by using array? Int array ia equal to int stream arrays dot stream dot ia. Look at here, already stream 2 has completed na, just for testing. I want to work stream 2 one more time. Stream 2 dot for each. What happened? Let's see now. We got error. Already stream is processed. Illegal state exception. Stream has already been operated upon or closed. It's already operated and closed. Why you are using again? Stream is reusable or not reusable? Not reusable. Everyone understood? Then tell me now. I want a stream object like this. Stream int stream I have gotten. Okay, this is completed. No. This is an array. Tell me. Now I call arrays dot stream of IA. IA is what type? Int type, na? When you're working with integers, I told you which stream we use. Int stream. Okay, na? Int stream. For example, if these are long values, long stream. If they're double values, double stream. Sir, I have different type of values, sir. Then use stream. Okay, source and then what? Terminal, just retrieving elements. Created source of elements and retrieving those elements. Clear? Now, I want to create a collection object. Look at there, I have created list dot of collection of elements. I can create list object, collection object by using of method. First, observe carefully. Arrays dot stream. Here it directly we created stream, but I want stream from array. Here I want to create stream from list. What is the method you have to call? List dot stream. Then source ready. On that source I have applied terminal. Adhiksha, did you notice? I was using here functional method reference. Here I am using method reference. First two option lambda expression, next two operations, I'm using method reference. Why? Because the value taking from the stream and just printing. Now for each method take the first element passing as an argument. Again loop iterated, second element passing. Third iterated passing. Fourth retrieving passed. Fifth retrieving passed. Sixth retrieving. For each method implicitly contain for loop for retrieving objects available. Okay. Then now I want to retrieve the values from the file lines. Okay, abc.txt. I have created one file here, abc.txt. 1 minute, you may copy from previous project. Okay, abc.txt contain multiple lines like this. Hari Krishna, Naresh IT Technology, Samirpet, Hyderabad, Telangana, pin code 5,16. Okay. Now I want to read those lines by using stream API. I don't want to write that entire for loop all the jamana over. Hope all the people know how to read number of lines from the file by using br.readline by writing for loop. What is the target of our functional programming? Avoid for loop. In place of for loop, what I can use for each method. But for each method, should call on where stream. How to obtain stream on buffer reader lines method. Call br.lines method, retrieve the stream, apply for each, pass the br.readline. Pass the method reference, it will retrieve the values and print. Okay, you have to type this entire code in your system compulsory. If you type, then only you will understand. If you don't type, you will not understand. You will not remember. Okay, na? Tomorrow, can I cover Stream API entry questions? Stream API completed. Now I'll cover some more examples. Intermediate operations we didn't learn. I will apply some intermediate operations. Tomorrow, if you want, if you have patience, sir, every day boring, sir, and today I'll close the session. More 10 minutes I will take, wait, don't go. 10 minutes more, 10 minutes class is there. Yeah. That's what entry questions I'm asking. So if you want me to cover entry questions, I will cover. Flattening, reducing, sorting. Okay. Look, because daily strength is decreasing. Maybe they are busy with another classes or what, I don't know. So that's why I'm asking. Okay, look at here. I'm using intermediate operations. Look at here. I called what? List1 dot stream. Can I reuse the list? Can I reuse the list? Yes. We can reuse the list. Can I reuse the stream? No. Then list1 dot stream I called. Then what I did? Simply taking values available in the list and printing. I have just applied what and what? Source and terminal operation. But now I want to learn applying intermediate operation. I don't want every element to print. I want to print only the elements available in the list, even numbers. If it is a old style, before Java 8 style, can you tell me how to write the code? I should write for int value colon array, list1, open bracket, system dot out dot println system.out.print, let me take for showing the difference value. System.out.print. Look at their control F11. All values are printed 2, 3, 4, 5, 6, 7, 8. I'm taking one line gap here plus double quotes. Now control F11, all values are printed. Old style I'm teaching first. I don't want all values. I want only even numbers. Then I should write one if condition whether to execute this line or not. What do you write? If value mod 2 equal to 0. What is this? This is a condition. This condition is working on only one object or every element available in the list? Every element. Then what is printed? Only even numbers are printed. 2, 3, 2, 4, 6, 8. Can you explain me how it is working on? Explain the flow of execution, very important. For loop first taking element from the for loop, taking the first element and stored here. What is the first element? 2. This is 2. Now if condition is working on that element, 2 mod 2 equal to 0, true, then print. Loop iterated. Then for loop is taking second element and stored 3. 3 mod 2 equal to 0, false. If condition not executed. Loop iterated. Next value is what? 4. 4 mod 2 equal to 0, true. Then 4 executed. 2 printed. The next what? 4 printed. Then loop iterated again. Loop iterated again. What is the next value coming out from the list? 5. 5 mod 2 equal to 0, false. If condition not executed. Loop iterated. Everyone understand? Loop iterated. Then inside the loop, what is again? Next value coming 7. 7 mod 2 equal to 0. 6 na? 6 mod 2 equal to 0. True. True means what? SOP will execute. Like this, for each value available in this element, you want to execute if condition or not? Tell me, this is a old style code. This is a declarative approach? No. This is an imperative approach. Declarative, imperative. Imperative and you are writing if you are writing everything. Declarative means I will tell you write. That is declarative. I am declaring, I am telling. I will tell, take this condition. If this condition is true, then give me value, else ignore. Hence, in Java 8 version, for represent this for loop, I have for each loop. What is your target? Your target is just printing the values. Your target is just printing the values. Then what is required? This for loop place just what is coming, for each method is coming. But now you want just display value now. You want for each value check the condition now. Apply the condition on for each value. Apply the condition on for each value. Further, again for loop required or not? Now I required only for loop? No. For loop with condition. For loop with if condition. Further, another new method is provided. For loop with condition, one more method is provided called what? Filter. What method name? Filter. Here for each what is doing? Taking, printing. Here filter what is doing? Taking and checking condition. I am rewriting this entire old code as Java 8 code. Observe Java 8 code I am writing. First obtain the stream again because previous stream already dead. Obtain the stream again on the list. Second, after obtain the stream, just take the object from the stream, take the object, print, take the object, print, take the object, print, take the object, print, completed. But you want to print every object? No, only even object. That means before printing, I have to put a condition or not? Then stream 6 dot already stream source is available elements. Stream 6 dot there is method called what? Filter. Everyone answer? Filter implicitly contain the loop na? Filter implicitly contain loop. Filter implicitly contain the loop. Take the first element and giving that element as argument to your lambda expression. Now the lambda expression should print a check and return boolean value. Take input, check and return Boolean value. Check and return Boolean value. Tell me, this lambda expression representing functional interface means filter parameter is what type of parameter? Which functional interface? Here parameter is what? Excellent, super, marvelous. Predicate. Taking input, returning Boolean, predicate. Look at that filter predicate. What should I pass? Take the element. You should write the logic. If element mod 2 equal to 0. Okay, equal to 0. Then assign to a variable. Assign to a variable. Stream of integer of filter 7. Okay, tell me, once you apply the filter, it process the data and generate the new values, na? Then new values are available in this stream. Then here I am, finally, you want to retrieve the values from stream 6 or stream 7? Stream 7. Can I take stream 6? Can I use stream 6 again? Can I use stream 6 again here? No, because stream 6 is already processed. Let's see what happened. Throwing exception, illegal state exception. Already it's processed. So what I should write here? Stream 7. Control F11. What is coming? Only even numbers 2, 4, 6, 7. Can you tell me how even numbers? When you call filter method background create one stream object or not? Yes. Filter method taking first element from the streams 2. 2 is passed. 2 mod 2 is equal to 0. True. Then include comma. The next coming value is filter method again contain loop, retrieve the next element and passing here. What is that? 3. 3 mod 2 equal to 0. False. Don't include. Ignore. Then filter method taking the next element and next element mod 2 equal to 0. True. Add here 4. Next element 5. 5 is mod filter method taking 5. 5 pass as an argument. Argument mod 2 equal to 0. False. Ignore. Loop iterated. Filter method will include that object in this stream only if the condition returns true back. That is the point. Everyone understand? Filter method again taking what? Next element. What is that? 6. 6 mod 2 equal to 0. True. Include. Loop iterated. 7. 7 is mod 2 equal to 0. False. Ignore. Filter repeated taking next element 8. 8 mod equal to 0. True. Then add 6 comma 8. And then now I am applying the terminal operation retrieving and printing all the elements. Okay, buddy? Everyone understand this? Source, intermediate and terminal. Everyone understood? Any confusion here? Please tell. I explained with internal flow of execution also how it is working. Everyone understood? Can we go to the next operation? Okay, very important. Variables chapter. In variables chapter, I told you when you are using variable only one time, don't create. I told you no. This stream is multiple usage or only one time usage. One time. Then every time assign the variable, use that variable, assign next variable, use that variable. This is a lengthy process. That's why. Tell me, when you are working with select query, how you are working? Select query, first store, again on that query, apply where, on that apply and on that apply or in the pipe you are applying, in the pipe connection you are applying. So stream API is nothing but select query with where condition. Select star from student, where, and like that. So first you call list.stream. Stream is returning the stream object or not? On that stream object dot, can I call filter? Filter returning the new stream object. On that stream object, can I call for each? Yes. I can avoid using the variables. Stream 6 is nothing but list.stream. Stream 7 is nothing but list.stream.filter. Observe here, I have written like this. Which one is more easy to read, understand? Method called chaining or individual variables? This is called method called chaining. We are chain the methods. One method call chain to another call chain to another method. And tell me, from here data flowing to filter, from here data flowing to for each, finally data coming. Okay, practice method call chaining. First list dot stream, then apply filter dot filter. This dot is coming to here. And then why you take in the next line, sir? Just to show you what happening here. Here stream object is created with all elements. Next line dot stream. Okay, now it is printing only, it is creating a new stream object only with the mapping value. Okay, and now this is the final filter applied on result stream. Tell me, final terminal operation returning the result or stream result? Okay, will you all practice up to here? So we completed stream API introduction, different ways of creating, applying intermediate operation, terminal operation. First stage completed. With this, if you want to learn yourself further, you can learn. No, sir, you only cover. We are free. We will listen and I will cover tomorrow. Next level interview questions. Choice is yours. Shall we wind up workshop today or shall I continue tomorrow? Continue? Will you come? Time 11:30 only. Okay. Time same time, 11:30. 11:30 to 1. Tomorrow I'll teach you filter completed today. Okay. Tomorrow again I'll cover filter, map, flattening, reduce. So many others, so many points are there. I will cover with custom objects, everything. You asked me explain the sorting. Sorting I'll explain. All whatever there, maximum we'll try to cover. Converting one stream to into stream, double stream, mapping operations. Okay. Yeah. Thank you guys. See you tomorrow. Thank you so much for attending today class. Tomorrow 11:30 stream API entry questions. Don't miss tomorrow class. Thank you. I'll upload this material into your